Hey everybody, this is Mr. Munson. We're in Unit 10, Transformations. This is concept number 2, part 2, Reflections. What we're going to be looking at is taking objects and reflecting them over a line. Let's go ahead and get started. Okay, let's do some line basics before we get too deep into this. Let's take a look at how would we draw an equation like x equals a number. In this case, I'm going to look at x equals 3. Now, x equals 3 is a vertical line, and it goes through the x at 3. Now, keep in mind, we always want to identify our line and write it into the graph like that. So whenever we draw a line, we always write the equation next to it. So this would be x equals -2. This would be x equals 0, or known as the y-axis. Okay, let's take a look at something like this where it's y equals a number. If it's y equals a number, such as, let's say, y equals 2, let's get rid of that. That it's a horizontal line that goes through the y-axis. Again, we would want to write down next to it the name of the equation just like that. Don't forget to do it. Now this would be like y equals -2 and y equals -4, and the reason is because it crosses the y at -4. This would be y equals 0 because it crosses the y at 0. It's also known as the x-axis. Now let's look at these two. We have y equals x, and then we have y equals -x. Very similar graphs. So what I know is in this equation, y equals x. It's in that slope-intercept form. And we know that this number right here is where it crosses the y-axis. Now there's nothing written here, so that implies it's a +0. In other words, it crosses the y at 0. So I'll put a point there. Now this also has a slope, right? That's what slope is. And the number in front of the x is a 1. So we become 1 over 1. As you can see, my graph has already been drawn there. And so we could have created that line by simply putting a point at the 0 and going up 1 over 1, up 1 over 1, and then draw the line. So this is x equals, y equals x. And of course, I'll label it. All right, see if you can do y equals -x. It's very much like this equation, but it has a negative slope. Put me on pause and see if you can do it on your own. All right, and there you have it. And again, it's has a y-intercept at 0, and it goes up 1, -1, up 1, -1. It creates a negative slope. All right, let's take a look at this one off to the left. This is going to be an equation y equals -1, so you should be able to draw that horizontal line. So go ahead and draw that line and plot this point. Come back and check with me as soon as you got that done. Put me on pause. Go ahead and have that done. Okay, so you should have put a line here. Don't forget to label it. And then you plotted a point at 2, -3. So should be a point down here at 2, -3. We'll put that right there. Now what we want to do is we want to reflect that point over that line y equals -1. It's a real simple task. All you got to do is count directly to that line. We would walk straight to it. There's 1, 2. So A is 2 units away. So let's repeat that above it. 1, 2. So right there is A prime. So one of the things I want to point out is that whenever you do a reflection, if I was to draw a line between the reflected points, it will always create a perpendicular to the line of reflection. So the point above 2, -3 maps to the point 2, 1. And we call that A prime. So put me on pause, and what I'd like you to do is see if you can actually do this point on your own. Reflect that point across the y equals -1 equation. Okay, so I got -2, 5, a little bit off my graph. No worries, there's such a place. And I did that by simply going to C and counting to my line of reflection. So 3, 4, and then I'm going to just continue that in the same direction. 1, 2, 3, 4. And of course, that would be -5. Cool. Let's see if you can do this next one. Go ahead and put me on pause. Go ahead and draw your equation for x equals -2. Plot the point -4, 3, and then reflect it. Okay, so I got the point 0, 3, and hopefully you did too. So pretty much in this section, we're going to be reflecting across vertical lines, horizontal lines, and now let's take a look at diagonal lines. All right, and I'm sorry for coughing there. So take a look. Let's see if you can at least draw the line, y equals x. We've done that already in the basic line stuff, and plot the point. Put me on pause. Have that done. And if you want, try to reflect it. See if you can think through how the reflection would be. Keep in mind that your point of reflection and your original point will create a perpendicular line to the line of reflection. All right, put me on pause. At least draw the line and put down the point. So there's the y equals x, and we label that, of course, and then we'll plot that point. All right, and we'll call it A, of course. Now we're going to reflect that. So what I'm going to do is when I'm dealing with a reflection across a diagonal line, I get to count diagonally. So as I move from A, I'm going to move 1, 2, and 2.5. So I'm going to take that 2.5 and count diagonally on the other side. There's the half. Okay, that took care of the half. Now I just need to count 2 more. 1, 2, and there's A prime. Very simple stuff. Now there's a rule for this, and the rule is I'm going to take my x and y, and I'm just going to flip it, and it becomes y comma x. So if you take a look at point A is -2 comma 3, and A prime is 3 comma -2. Whoops, -2. Okay, so the rule absolutely applies. But if I can't remember the rule or I'm stuck, you should be able to think through how to do it on a graph. All right, let's go ahead and move over to this one. Go ahead and draw these. See if you can do the diagonal reflection. Put me on pause and come back and check your work. All right, so there's my line, and there's my naming of the line. I'm going to plot my point at 1, 3, and then I'm going to go ahead and reflect it. 1, 2, so it's 2 on the other side. 1, 2, and there's B prime. And of course that does follow the rule. B here is 1 comma 3, and B prime is -3 comma -1. Wait a minute, that's a different rule than this one over here. This one over here was just flip the coordinates. I flipped the coordinates but took the opposite of them. And that makes sense because we're reflecting across a different line. The rule here is going to be take your x and y and map it to the opposite of y and x. All right, last up, we're looking at reflecting through a point. Now, when we go to reflect through that point, what we want to do is take the point S, which I have drawn here already, and we're going to reflect it through, in this case, the origin. That point is known as 0, 0. Now, in this class, that's the only point that you're going to have to worry about reflecting to. Okay, so let's put a point right here at 0, 0. And so what ends up happening is I'm going to walk there. Now, if you take a look, if I walk diagonally to that point, I'm going to miss it. Okay, so that's not going to work for me, that way of walking. So I'm just going to simply draw my line in that position there. And what I know is that that point S prime is going to be the reflection same distance away and kind of in that same line. So let's just kind of create a line, kind of keeping it straight there, and it points to where this new point will be. Okay, now these two lines I can eyeball them, they're about the same, and I just simply drew it. Well, keep in mind that when I reflect it through these points and these lines, in many of these cases, the numbers stay the same. They just change their order. So I have a 4 and a 3 in this one. I understand that there's a negative there, but I have a 4 and a 3. So my answer is going to have a 4 and a 3 in it as well. So over here, I can see this point right here at -4 comma 3, and that will be my S prime. Get rid of that. Kind of a mess. And there we have it. Okay, so let's see if we can work together. I'm going to have you put me on pause and see if you can come up with a rule. Now, take a look. We have this point, the original point, 4, comma, -3, and it maps to, when you reflect through the origin, it maps to -4, comma, -3. Oops, not -3, +3. I'm sorry. Right? Okay, so what I want you to do is I want you to see if you can come up with the rule that makes sense for when you map through the origin, okay? So I'm sitting here at 4, -3, and it maps to this 4, comma, -3, or 4, comma, 3, -4, comma, 3. All right, so see if you can come up with the rule, and like we have had in the past. Go ahead and put me on pause and see if you can come up with that. Well, that looks like it to me. It takes the x and takes the opposite of the x and takes the y and takes the opposite of that. And that will be the rule for reflecting through 0, 0. Now notice I came up with the idea not using the rule, but just intuitively realizing that these distances from each other, from the s to the point of reflection, is going to be the same on the other side. And it's not going to all of a sudden kind of bend and go up, you know, and reflect in a weird way. Okay, so it's going to be right in line with the reflection. Cool. All right, that's it. Go ahead and go ahead and put me close out the video, and let's get some practicing done.